This is part 2 of our 3-part series on building RESTful Web Services the easy way. In this part 2, we're going to focus on a really cool toolkit called Spring Boot. Spring Boot is one of many toolkits or projects, as they're called, offered by Spring. The Spring framework is probably the most notable of these, but if you go to spring.io and you go to the Projects tab, you will find all of the Spring toolkits or projects that Spring offers. And there are many of them. And basically, all these things do is make your life as a programmer easier. So today, we're going to focus on using Spring Boot in combination with Spring Data JPA for our database access to make developing RESTful Web Services really, really easy. In fact, I'm going to go so far as to say that this may be the easiest way to build RESTful Web Services I've ever seen. Now, there are some limitations, and we'll get to those in a little bit. But before we go too much further, let's just take a quick look at the app itself that we're going to be developing. It's a simple app for managing hotel information. And so here we have a running website. By the way, we're running this website on a separate server. Notice the port number is 8383. I did that on purpose because I want you to learn how to deal with web services the way they're typically used, and that is they're running usually on a separate server. In our case, the web services are not running on 8383. They're running on port 8080, so they're running on effectively a different server. And we can access those web services from any other app, in this case, our little hotel manager app. And so we're going to show you how that all works as well. But basically, this app is a simple CRUD, that means create, retrieve, update, and delete, a simple CRUD-based web app for managing hotel information. So as you can see here, we have a list of hotels. And when you click on one, that detailed information is retrieved from the web service and displayed. We can modify it if we'd like to. Okay, let's just modify a record. Let's modify this one here. So let's pretend we misspelled it. We'll change the C to a K. We'll hit save. And as you can see, it was updated immediately. Let's see, we can delete records. We'll delete this Hotel Allegro. As you can see, it was deleted successfully. We can create new hotels. My Hotel, 1234 Street, Milwaukee, Wisconsin, 53202, save. Successfully created, and you can see it was added down here. So it's a simple CRUD-based application running on one server. This is the client-side code only. There's no server-side code in this app, and it's pure HTML5 and JavaScript. And then we're accessing a different server, which I have running in this console output. We're running on port 8080. As you can see right here, port 8080. And it's actually Tomcat. We'll talk about this reason for this server in a moment, but we're actually running all the server-side code in Tomcat on port 8080. That's where our web service resides. And then we're running the client-side code on port 8383 using a built-in mini server that is supplied with NetBeans. So, and the reason I'm doing it that way is it's just easier to show two different servers talking to each other. Now, another thing to keep in mind is that normally this would not be allowed. By default, web services can only be accessed for security reasons from the same server. In other words, your client-side code has to be running on the same server. But that's not very useful with web services. We want those services to be available to other servers, typically, although it's not a mandatory thing. So you need what's called a CORS or cross-origin request filter, and we'll show you how to do that as well. Okay, so now that we've seen a general overview of our application, let's take a look at how it's coded. We'll start with the server-side code. Now what I've done is I've built this little app called RestHotel in NetBeans using Maven. Now the reason for using Maven is severalfold. First of all, by making it a Maven project, we can run this in any IDE. I could use Eclipse, I could use IntelliJ. Maven projects have the same structure, and therefore you can run them on in any IDE. The second reason is to manage the dependencies, in particular the Spring stuff that we're going to be using. So here's the Maven POM, and again, if you're not familiar with some of these terms, Maven or the POM, there's notes there's video notes below that you can check to get more information. But this is the Maven POM, and as you can see, we're going to be using a parent POM to retrieve what's called the Spring Boot Starter Kit. So this parent POM has all the Spring Boot stuff that we need to get started. As of the creation of this video, the current release version is 1.14. That may change in the future, so keep track of that. There may be API breaking changes as well, but that's the version we're using right now. And then what you're going to want to do is you're going to want to have some basic properties, in particular the startup class. We'll talk more about the startup class in a moment. And then the following dependencies. Now we're going to be building web services, so we're going to need the Spring Boot Starter Web. We're going to need the starter data JPA. So the starter web, what that does is it loads all the Spring dependencies that are needed to do a web project. The starter data JPA gives us all of the Spring dependencies that we need for accessing a database through Java persistence architecture. And then we're going to need a dependency on, in this case, we're going to use an in-memory database. And we're going, although you don't have to, you can use a real database, but just for the sake of this demo, it makes it easier. We're also going to need Spring Data REST, WebMVC libraries, and we're going to need, if we want to do some testing later, the test starter plugins. Then the rest of this is just basic Maven stuff. We do have to identify where the milestone releases come from Spring. But basically, this is all there is to the Maven POM to get started with Spring REST and these Spring RESTful Web Services. Now, once you've got your POM correctly, you're going to want to do a clean and build so that all of the dependencies are downloaded. So once you do a clean and build, I've already got them all downloaded, but you'll see a list in the output panel here of all the dependencies being retrieved. So now you have all your Spring stuff, all your Spring libraries that are needed. Now watch how simple this is in terms of getting an application built. The first thing you're going to need to do is create some packages. Now, what I learned the hard way is that what you need to do is have package names that are consistent. Notice that the prefix is always the same here, edu.wctc.spring.boot.rest. So every single package begins with, and then demo 1. The name of the package is irrelevant. You can use whatever name you want. But notice that every package has that prefix. So here's the root package. And then after the root, we have a sub package called domain, then filter, and then service. Again, you don't need to have these specific package names. But the important thing is that your startup class should go in the root package. Don't forget that. I forgot to do that. I had demo1.app, which is not the root, and it didn't work. So you've got to have a package name that represents the prefix of all of your other packages, and that's your root package. That's where your startup class goes. Let's take a look at the startup class. Again, the name of the class doesn't matter. I'm calling mine sample data REST application. It's just a normal class with a normal main method. What's different about it are all these annotations. And these annotations do a whole bunch of work. First of all, it auto-configures everything. Now, if you're familiar at all with Spring, you'll find that there's a lot of XML configuration involved in many cases. This does everything automatically. No need to do any of that. Component scanning is something that Spring can do to do some things called dependency injection. Enabling JPA repositories, that's going to get us our database access. We have to use this import tag to import what's called the repository REST MVC configuration class, and that's, again, just something that Spring Boot needs to get all this to automatically work. And then enable automatic auto configuration basically just tells Spring Boot to automatically configure this thing for us based on these other requirements. Then the only other thing you have to do is tell your is use this static method run on the Spring application class and then reference your startup class like this as a parameter, and then comma the args that are being passed in. That's it. That's all it takes to start up the app. Now we do have some other code though, but you won't believe how simple this other code really is. First of all, we're going to need a domain class. So we're going to need what's called an entity class or domain class in JPA terminology. And basically, entity classes, you can see the annotation entity, which comes from the Java persistence architecture. You can basically, an entity class represents a database table. And you can either write these manually or you can reverse engineer these from a database. NetBeans has wizards to reverse engineer entity classes from database tables. I'll be showing you that later, but this one's already been created, and basically an entity class has properties representing the various columns in a database table. So you need an entity class. Okay, that's relatively simple. Then you're going to need, and this is really the only other thing that's mandatory, you're going to need what's called a repository class. Again, the naming isn't all that critical. You don't have to call it a repository class. But basically, what it is just an interface. Yes, it's not even a class. It's an interface. I happen to call this hotel repository. You want to inherit from another interface called JPA repository. This is a Spring class. You pass it the entity type, which is hotel. So in other words, this repository is really just an interface that gives you access to CRUD methods to access the hotel information. And then the type of the primary key, which in this case is a long. Now, for the moment, ignore this because this is an optional additional feature. So for the moment, we'll just ignore that. The only other thing you have to have other than an interface that extends JPA repository and has the entity type and the primary key type as generic identifiers, the only other thing you need is this one annotation. Repository REST resource. Collection resource. This is, these methods oftentimes return a collection, so we're referring to that as hotels. And the path, in other words, the web service path, is hotels. And you'll see how that works in a moment. All right, so all you do is create an interface with this annotation, and that is it. Spring will automatically create an instance, a concrete object from this interface. Actually, it creates a class, and then it creates an object. And it'll automatically create all the CRUD methods for you. Not only that, but because of this annotation, it's going to automatically create all of the related code to turn those CRUD calls into web services. We don't have to do any of the coding. If you take a look at part 1 of this series, you'll see how we did the coding manually in NetBeans. All of that's gone. All we have to do is create an interface for each database table that we want to access. So that's pretty simple. Now, optionally, you can create a CORS filter, which I've done, because remember, without the CORS filter, you can't access these web services from other websites. Be sure when you create the CORS filter, and you can just literally copy and paste what I've provided here. By the way, all this source code is on GitHub, and there's a link to that code in the notes below. But be sure you put the appropriate access control headers that you're using. Usually that's going to be content type. And be sure you put the appropriate HTTP methods you want to allow. In my case, I'm using patch. Not everybody uses patch, for example. Be sure you have those, or you're going to get access denied messages. So by providing this filter, you automatically get the benefit of accessing your web services from other domains, from other servers. So let's take a look at what the mandatory parts are and what the optional parts are. At minimum, you need to have your POM configured correctly. You need to have a startup class in the root package. And that startup class has very little code in it. You need to have a domain class for each database table that you want to access, and you need to have a repository class interface for each of those entities. That's it. Now, optionally, you can add your CORS filter if you want to access your web services remotely. All right. Now, everything that you've seen here is all that's everything you've seen so far is all that's really necessary. However, it's nice to have some data to start playing with when you're developing. So by placing a file that is explicitly named import.sql in this other sources, source main resources, default package, but in other words, it's at the root of the class path, and having insert statements to insert some sample data into your database, what Spring Boot will do is it'll automatically initialize this data on startup. There's also optionally this application.yml or YAML as it's referred to that allows you to configure some other things, different profiles, what have you. You can read more about that in the Spring Boot documentation. But essentially, that's it. So here's another really cool thing about all of this. Not only have we got a fully database connected CRUD based set of web services with very little code, very, very little code. Not only do we have that, but this actually creates an executable jar file. Let me show it to you. Here it is. This is just a jar file. All you have to do is run this as a standalone Java app on any server. In other words, you could mail this. You could email this to anybody you want. And they could, if they have Java installed on their computer, they can run this. What does it do? It starts up an instance of Tomcat. It starts up an embedded instance of a database server. And it runs it on port 8080 by default, although all of that stuff can be configured and changed to your liking. There's no more need to go through the complex process of installing and configuring a web server. You can simply embed it. Spring Boot embeds everything in this jar file. So now you can run this wherever you want. Now there are some downsides to that, but that makes it really convenient for demonstration purposes, really convenient for demo purposes to be able to dispense with all of that complex web application server stuff and simply be able to run this wherever you want. So let's see how you do that, how you run it. All right. You can use any terminal. If you're on Windows, that would be the command line, the command prompt. If you're on a Mac like I am or a Linux box, you're going to have a terminal application. But NetBeans, if you're using NetBeans, and a lot of IDEs like IntelliJ, for example, have a built-in terminal emulator. In NetBeans, you can simply go to Window, Window, IDE Tools, Terminal. And you will get a terminal window like this. Like this. Let me just clear the screen. And of course, you have to know your terminal or command line syntax. But what I'm going to do is I'm going to cd to the directory where the target is what Maven uses as a location. See, we're in the target directory. Target is where, so in your app, here's my app. Inside of that app is this target directory. Inside the target directory are the jars. And so what I'm going to do is I'm going to go to my terminal in NetBeans. I'm going to cd to that target directory. Now I can type ls to list out the contents. You can see there's two jars. One's got a .original and the other is .jar. .jar is the executable one. So we're going to use that. And in Java, to launch an application that is compiled as a jar file, all you do is you type java -jar. So there's a space between the -jar and Java. Then another space, and then the name of your jar file. Now, using auto-completion, I can just hit tab, and you can see that it is now going to try to run this jar file. When I hit enter, you'll see that the Spring Boot logo will appear. You'll see a lot of command line output about what it's doing. Some examples of what it's doing is it's initializing Tomcat. Right here you can see that. Something else that it's doing is it's auto building, it's exporting the schema definition of our database. Right here you can see running schema export, and it uses that import SQL file to do that. And it tells you all the other things that it's busy doing. And when it's done, it says, hey, it's ready. You can use this. So let me open another terminal window and demonstrate some of the things you can do with this. I'm going to use a command that's included in on the Mac and on Linux boxes called curl. And what curl does is it lets me access any network available resource. So I'm going to curl localhost 8080, which is where our app is running, and then I'm going to do /hotels. That is the path to our web services. And just to remind you of that, in our repository class, you'll notice that we have this path setting set to hotels. So that tells us that to get to the web service, we have to have hotels in the path. When I click enter, watch what happens. We get all of the data formatted as JSON. But it's not just JSON that we get back. We get JSON formatted data that includes what's called HATEOAS, or HATEOAS. And HATEOAS is also automatically provided by Spring Data JPA. And what HATEOAS does is it gives you not only the data, for example, here's the data for this particular hotel, the Brisbane Hotel. You can see there, that's the city, the name of it is Conrad Treasury Place, the address, the zip. But it also gives us information about how to access each of these. So for example, to access this particular hotel, this Ritz-Carlton hotel, it gives us a link to itself. Let's try that. Let's try curling to that. Okay, so let's do curl. Again, HTTP localhost 8080/hotels/2. And now we get just that one hotel. So what HATEOAS does is HATEOAS is a technology that is becoming popular with web service developers to provide a way for data retrieved to essentially define itself and to define related links to other information. So what you see here is that we get all the various pieces of information we asked for, but we also get links that help us dig down further. So when I asked for all the hotels, I got the data for all the hotels, plus I got links to the individual hotels. When I asked for this single hotel, it described itself, and that's it. So that's basically what HATEOAS is all about. Again, more information on HATEOAS can be found in the notes. Okay, so now what do we do with all of this? Okay, so we've got a running app. Now we certainly don't want to be using curl to get at this stuff. We want to create a web app that gives us a pretty front end. So for that, what we're going to do is we're going to develop a separate app. And again, I'm using NetBeans. I created a HTML web app. So if you look at creating a project in NetBeans, one of the project types is HTML5. So I created an HTML5 web app. That's this RestHotelClient. And what we have here is the HTML. Here it is. And the JavaScript that really is the secret sauce for accessing web services. And all of this is written using JQuery. There's no other JavaScript frameworks as there was in part 1. This is just jQuery. So basically, what you need to do is you need to identify what's referred to as the root URL. And in my case, that is our server that's running the web service. And remember the path, hotels. So that's how you get to the web services. Now I've got some other variables, for example, a place to store the current hotel when we access one, etc. And then I want all of the hotels to be found when we start things up, so that we can see our list of all the hotels on the left here. So let's just take a peek at how this works. Let's look at find all. So if we scroll down here, we get to the find all method. Here's the find all method. Now this is not mandatory. I'm doing some console logging just so I can do some debugging. But the way you use jQuery to access a web service, so you use their AJAX feature function. When you're retrieving something, you're using an HTTP GET method. So this is the type of method we're executing. We want to access a particular URL, and we're using that root URL that we mentioned earlier. There it is. And we need to tell it what type of data. What is the format of the data that we expect to come back? Now, this is typically referred to as a MIME type, M-I-M-E. And a MIME type is one of many published, these are MIME types. And you can see here's a MIME type for MIDI, MIME types for various kinds of images. But the one we're most interested in is the JSON format. So let's see if we can find that. JSON, there it is. So this is the MIME type for JSON, application/JSON. But jQuery has an abbreviation. You can just type JSON, and that translates into that MIME type. So we tell it what method we want to use. We tell it what the URL is. We tell it what type of data format we're expecting. And then we execute what's called a callback function if it's successful. So if successful, call render list. Well, here it is. Here's the render list method. And the data being passed in is what comes back. That's our JSON formatted data. And right now I'm not using this line. All we really have to do then is access the data within that structure. So basically what I do is I loop over the underscore embedded hotels subobject of this data object. So to give you an idea what that is, if you look at what we get a bunch of links when we find all. We also get this embedded subobject. So under the data that comes back, we get links. But we also get embedded, underscore embedded. And within that, we get hotels. So this is all the hotels. So what you see here is we're saying, go dive inside of that data, go to the embedded object, and then go to the embedded hotels object within that. Then we can execute this function. So for each of those objects, execute this function which keeps track of the index and the object that we're iterating through. And what we're really doing here is we're getting from that object is the hotel, go to the links, underscore links, .self.href. So going back to here, we've got link, underscore links, self, href. And what that does is it gives us a link to that specific hotel. So what this routine is doing is it's modifying the list elements of the unordered list in our HTML. So let's take a look at that. Here's our unordered list. Oops, just a second. Where am I here? Here it is. Unordered list. Oops. Hotel list with the ID hotel list. So we've got this unordered list in the left area of the screen. And what we're doing with the JavaScript is first we remove the previous entries, and then we append to the unordered list new li items with links to the href for that particular hotel. Plus, we use the hotel's name as a display. So if you look at the display, we've got the hotel name, and for each of these, we have a link. So you can see that link in the status bar below, or if you want to do an inspect, oops, if you want to do an inspect, gosh darn it, sorry about that, inspect element, you can see the link right there, right there. So each of these functions provides a different piece of the puzzle. Here's the function for adding a new hotel, for example. And of course, when we're adding a hotel, we're doing more than just retrieving data, we're sending data. So how do you send data? Well, first of all, your AJAX method type has to be post. The content type that we're sending is JSON. Now here I'm using the actual MIME type. I could have used the abbreviation, but I'm using the actual MIME type. The root URL, the type of data we're expecting back, and then we need to somehow compose the data that is submitted in the form. So when we create a new record, we're filling out this form, and we need a way to compose that as JSON formatted data and send it to the server. Well, that's what this routine does, is form to JSON function. So you'll see that down here. And basically what happens is we take this stringify method provided by this jQuery JSON helper, and basically we take the value of each of the form elements that contains our form data, and we turn that into JSON. So this gives us the JSON formatted data, and that's what's used to provide the actual data payload that gets sent to the server in our post operation. And then we have success callbacks and error callbacks depending on what happens. So basically, all of the code that we need for accessing a RESTful Web Services is written in JavaScript, and in this case with the help of jQuery. So as you can see, oh, and by the way, I'm using jQuery 2.1.1, and that's important because there are some API changes that happen that are significant since I think version 1.7. So if you're using an older version of jQuery, you're going to want to read up on the API changes that were made. But this website is pure HTML5 and JavaScript. There's no server-side code whatsoever. It gets all the data it needs from the web service in the form of JSON formatted data, and any data that's sent to the server is also sent using JSON. So what's really nice about this is that the data being transferred back and forth between client and server is really streamlined. It's just JSON formatted data. Unlike in a traditional dynamic web application where you're sending all of the code for the HTML page back, here we're just sending data back and forth. So it's very efficient from a bandwidth point of view. And it makes our apps really portable and really simple, because if you think about it, this client-side app is not dependent on my Java app web service running on Tomcat. What if I wrote a web service in .NET or in PHP or some other technology? This app, since it's just JavaScript, and since it just uses a URL to get at the web service, isn't dependent on any particular language or any particular technology. It just expects JSON formatted data to come back. That's pretty cool. And as you saw, the server-side code, because we're using Spring Boot, has very little effort involved in creating the actual code.